Hope you all ready for amazing speakers, Cindy, Giacomo, and Caleb from Xcel Energy and Lovelytics. I'm just going to give it off to them so we can give them as much time as possible.
Thank you. Good morning, everyone. I'll just introduce here. We have Cindy Hoffman here today with us. She's with Xcel Energy, and she is the Director of Enterprise AI and Data Science at Xcel Energy. Myself, I'm the practice leader for the Energy and Utilities practice at Lovelytics. And we have Caleb Morrison, who is a Databricks champion and Geospatial expert. Just a real quick background about Lovelytics. We are a elite Databricks partner. We recently merged with Newsot, and we are the largest Databricks partner that's not a global GSI. So we have a really big, strong presence in terms of onshore, Latin America, and offshore. And we have a lot of accolades and clients here that we could speak about more if interested. I'm going to pass it off to Cindy to give a little background about Xcel Energy.
Thanks, and good morning. Just a little bit of context for Xcel, for those that aren't familiar with the utility space. Xcel Energy is a vertically integrated, fully regulated utility and covers in 8 different states, but primary operations are in Minnesota, Colorado, Wisconsin, and then there's some in the panhandle of Texas, New Mexico, a little bit in the Dakotas in that area. So really up and down the middle of the U.S. But just want to to call out the context of, because we're fully regulated, vertically integrated, we cover everything from generation, transmission, distribution, all the way to our customers. So when you think about the data that we collect, it's a very data-rich scenario for us to work with. So Databricks and our AI capabilities has been fantastic to help us solution some of the use cases that have coming through the company at this point. So we'll dive into some of those in a minute. Do you have it? All right. Let's see. I'm going to pass it back to you for... Be a little bit better.
Sure. To give a little context, we want to kind of tell the Xcel story and kind of their modernization journey. We started working with Xcel Energy back in 2022 on a Consumer Privacy Act. And with that they needed to be compliant to understand where all their customer PII data existed. And we were one of the first to work with them to implement a large language model. We're able to identify where all their PII existed, across the organization, on-prem and in the cloud. And with that, we created an end-to-end solution on Databricks so that they could be compliant to the regulations. From there, because we had a good lay of the land of all the data, we were able to help them establish some data governance best practices and get a data governance tool and kind of establish the lineage and metadata and cataloging and setting up domains for the organization so they can kind of, organize their data in a way so they have the lineage and be able to work towards that North Star of self-service analytics. Still on that journey, but that's an ongoing, initiative there. From there, they had Databricks. This is an interesting story. They had Databricks for over a year and were struggling to get the full value of it. We worked with their platform team to kind of look at how they were as an organization from an analytics maturity perspective, how they operate as an organization, and kind of understand that current state and that future state. And from there, we helped them build and strengthen their platform in terms of building all the plumbing and to help a bunch of onboarding accelerators with Terraform accelerators to basically, cluster management, policy management, data ingestion patterns, and just all the plumbing to make sure that teams can be enabled to come onto the platform and get faster time to insights. The platform team did a lot of good work there, and they've taken it to the next level in terms of being a very scalable platform. From there, as you all know, Databricks is the modern stack that scales tremendously. We helped with a lot of it was with data science teams and getting them modernized onto the platform. Most of them, data scientist groups, work in different areas, data silos, third-party tools, Excel spreadsheets, what have you, and different sources of truth of the data. So, the platform was originally called the Unified Data Platform, with the concept to get everybody their data on the platform with single source of truth and trusted data, and then leveraging the modern stack. So by doing MLOps Kickstarter. We work with data science teams to get their data onto the platform, into the medallion architecture, and then leveraging the best practices of MLOps, GED, CI/CD, and spending more time on data science models and operationalizing those models. One of the first projects, big data lakes that was created was the AMI Smart Meter Data Lake. This was, ingesting all their meter data in a timely manner onto the platform, so they can do various grid visualization tools, anomaly detection, and understand, the current state of all their meters. We were able to leverage a lot of those onboarding accelerators for that and help accelerate that. The engineering team did a great job there of setting up all the data infrastructure for that to support that, so it can scale that large amount of data. Cindy, what is it, over 4 million meters?
Yes.
Okay, give or take, okay. From that, the next one was energy demand forecasting, also known as integrated system planning. This is where you understand the current visibility of the loads you have, and then also do more granular forecasting for the future to understand the impact of EV adoption, the hyperscalers demand, and just understanding the whole impact of the grid so they can basically plan accordingly. I don't know if you want to add anything there.
Sure. I think that one cuts across a lot of our efforts, where it's not just about meeting the demand, but there's also a lot of planning with our resource plan, and especially with the hyperscalers coming into our territories. There was a need to understand not only the load forecast, so that we've got pieces of that came into the anomaly detection and imputation models to make sure that we had a good demand forecast from the prior year and years. That feeds into the resource plans that we were going to need to file for meeting current and into the next 25 years. That feeds into our capital planning budgets, which then feeds into our distribution feed. So it's literally that little box cuts across 4 different areas of our business and almost the entire value stream of delivering energy to our customers. So that one, from an accuracy and an improvement perspective, was huge. We didn't have the ability in the past to actually run simulation models based on what we were seeing, and if there's changes, whether it was weather related, growth related, or anything. And now this is getting us to a point where not only we can get those models running faster and more frequent, but also it gives us the opportunity to look ahead a lot more and then have confidence across our states that we have to file regulatory models and make sure that we've got traceability and auditability back to those simulations.
And then more currently right now, the green boxes I'll go over right now, they have a large Teradata legacy install, 30,000 objects. We have a GenAI accelerator that's a brick builder, and we've mapped that out. I think manual, it was going to be 8-year project, but with the LLM, we can accelerate it by 80%, and it's roughly a 2-year project, and we're on that journey to migrate that all over to Databricks. As part of that, we've created a large language model to classify data, which is huge in terms of making sure that it's all classified properly for the regulations, and kind of work closely with Databricks to kind of build that large language model capability. And then, in terms of getting data on a platform, as you know, when you're on a platform, you can use the modern stack and a large language model. You get in the data in the Unity catalog. And so there's various large language models that Cindy's team's created. One is a rate case large language model. This is where you take in all that structured and unstructured data and put it in a large language model, and then supporting the whole rate case process, pre and post trial, doing accelerated analysis, and just helping them to get better outcomes when they do their rate cases. There was other large language models, poll decay, investor summary large language model, and many more. Her team's done an incredible job of leveraging the data on the platform and doing large language model to just accelerate all analysis and workflows. The next, that we'll do a double click on, but I'll just do high level, wildfire AI. This is, we worked with all the stakeholders to put a roadmap together to help look at their wildfire operations, and from there put together a roadmap of predictive models, fire risk models, to support the meteorology team and the whole operations. And a lot of this has to do with ingesting weather data, overlaying that with asset data, and then creating fire potential index models, wildfire risk models, asset risk of fire models. And we'll do a double click on that. Ends up being a lot of geospatial analytics that will show the specifics. A couple other ones that I just want to highlight. Insider threat detection. This is working with the cyber data. They have Splunk installed, and we ingest that data into a data lake called a cyber data lake. And they're doing anomaly detection for insider threat detection, so they can get ahead proactively if there's any potential data breaches and make sure that they can take care of that more proactively. And then grid modernization is a new one. This is noted as 3RE, risk, reliability, resiliency, where we're looking at all the grid metrics to understand, where their potential risks are, and basically having a risk model to understand which assets they should be looking to maintain accordingly. I don't know if you want to add anything there.
Just real briefly, on the grid modernization one with the risk reliability, what we're essentially doing is taking all of the events and tying them back to what needs to be investigated, so that can then turn into where we need to dispatch and do different types of work. This does feed into some of the wildfire efforts, because we talk about wildfire like it's an independent thing, but really it dovetails heavily into our distribution organization. So to the extent that we can find where we've got feeders or assets in general within, like, across our distribution and transmission plane, and tie that back before they would be potentially in a situation where they could be causing a wildfire or be tied to it, starts to dovetail together nicely. So maybe with that, I'll just transition to the next slide. And before we get into the technical pieces of the wildfire efforts that were underway, just to give you a little bit of context around, this wasn't just a model. It was multiple, like numerous different models. And just to do a quick walk through this, and I'll turn it over to Caleb for the deep dive. But when you start with your fire prevention index model, that's where we were looking at taking all of the weather, veg, all of your historical fire information, and trying to get that from, like, just an indexing, like, what is the chances of us having a fire? Dovetail that together with your asset risk. That ties in, as it says, your asset data, your outage data. What models are like the highest to cause a wildfire? Like, which ones potentially could spark? Which ones could potentially, cause other poles to have issues? And so it's like the two of them come together into a fire risk model. That has one output where it looks at just basically the HFRA is our fire ratings. And it's, think about tier 1, tier 2, tier 3. Like, which areas are going to have the highest area of potential risk from a fire perspective. But that fire risk model then goes into a consequence model. That's where we layer in our customer data. So when you think about, like, when we have a wildfire, so we understand who's it going to be impacting. Is it not just residentials, but where do we have hospitals, schools, critical infrastructure that needs to be maintained, and make sure that we can help then understand, like, where do we have to put, either partner with the local fire departments or whatever it might be, to make sure that we are in good standing to keep critical customers on and kind of help in that way. That one feeds into the situational awareness. That becomes like the bubble that everything else feeds out of. And so everything that's along your right-hand side is an output of that situational awareness, like the culmination of all of these. And I think, keep me honest, it's like something like 18 models total feeding together into that situational awareness center. And that's where you get everything from outbound communications to our customers, and that ties back to that one. PSPS stands for, I'm going to draw a blank now, Public Safety Power Shutoff. Thank you. I had a blank there. But it's the proactive, like, if we need to actually shut off power to our customers to prevent a wildfire, we have a communication out to that and that process. But also crew scheduling, pre-staging potentially. We've got the predictive maintenance, and then obviously veg, because if you can prevent veg overgrowth, a lot of times that will help with the preventive maintenance or the preventative nature of having a wildfire. So that's, in a very fast way, the nutshell of, like, all the things we're doing with wild from an AI perspective. There's tons of other things, but for this particular use case, That gives you a little bit of stage setting and context for what we were looking to accomplish with using Databricks and all of these different data sources coming together. So with that, I'm going to turn it over to Caleb, and he's going to do a deep dive on the tech side of making this all work.
So I just want to set the stage for Geospatial and GenAI and just talk about the overall, how we're driving business value. When we work with Xcel and other utilities, we always like to understand, the business outcomes and the use cases that drive business value. In this situation, the challenge is for most energy utilities, they have lots of image data, that requires a lot of compute, vector, raster, LiDAR, satellite imagery, what have you, and getting this data into a data lake so that you can standardize it and leverage it, in a modern way to create models for data scientists is what this is all about. We're able to get the data into a data lake, a geospatial data lake, and from there, enable the data scientists to create these complex models. From there, they're going to be able to, have this tabular data, get faster time to insights, with accelerated delivery, and just, obviously the compute and scale in Databricks is second to none. And, there's other competing platforms that try to do this and they can't scale. I think previously they were doing this on a separate platform, was taking 9 hours of process, and now it's like under 15 minutes. I mean, it's just second to none. So in a utility space, the big deal here is we're able to capitalize this development, which is huge, and reduce their O&M, overhead, which is what it's all about, and get them, using a modern stack. So I'll turn over to Caleb to give the deep dive on this.
Good morning, everyone. The geospatial solution that we're working with Xcel on involves a lot of geospatial data. You've heard some of these been thrown out there. Geospatial data is complex. If you've ever worked with it before, it comes in a whole bunch of different formats, a whole bunch of different types, and a lot of it is very difficult to work with if you come from a traditional SQL or Python background. There are usually dedicated positions in an organization to work with geospatial data because of all these, unique things with the data. So as G mentioned, we're working with a lot of satellite imagery, the big one being weather data. Wildfire obviously is heavily impacted by weather. So we're consuming a lot of data from NOAA. There are several models that we're grabbing data from. We're also grabbing data from other weather providers, both proprietary and governmental and open source, and bringing this all into Databricks. Giacomo mentioned the scale of the compute is second to none, and that is really critical to this operation. We were trying to do this outside of Databricks before, and it was just taking way too long to get the business the answers they needed in time. So you think about a dangerous weather situation, maybe where it's dry, very hot, high winds. That's a recipe for disaster from an energy perspective, because if anything goes wrong, a wildfire is very likely. And so we need to be able to take that weather data and figure out what do we do, not just for tomorrow or 2 or 3 days down the road, but also within the same day. How do we process this vast amount of data and come up with an accurate answer or prediction of what's going to happen, and then model that fire behavior as it grows? So that's kind of the root of the issue. What we found is that this process that we've come up with also ties back to a lot of other use cases, not just weather forecasting, but we're also able to use a very similar process for analyzing the data and applying that to vegetation type data sets, LiDAR data sets, and so on. So it's very reusable. We've been working with Databricks on a brick builder, and it's been a lot of fun. So the process for ingesting this data, what that looks like is we're going out to the various data sources. There are gigabytes, actually we're coming up on the terabyte range daily that we're processing for Xcel Energy, and some of that is vector data, meaning that it's data comprised of points. So you think about maybe getting guidance for a route, and it's driving you, to a destination. That's all vector data. We also have these satellite images and aerial photography type data sets where we can use those type of information to generate custom fire potential indices, and very helpful. And so we download all that data and we transform it from whatever format it came from into something that will be standard across the platform and then reusable across the platform. As part of that process, we have to index this data into what's called the H3 Global Grid Indexing System. H3 is a series of hexagons that covers the entire globe. This was developed by Uber and open sourced, and it's built right into the Databricks platform. So if you haven't tried that, go check it out. It's awesome, super high performance. And the H3 hexagon allows us to basically take any data, vector or image, apply it through this process, and come up with a representation as a string or an integer that references that same geospatial space exactly every time, no matter what system we're working with. No matter where the data came from, it all ends up in the same system. And so we're able to take these complex data sets and turn it into something that's very, very easy to work with. It's a very tabular format at that point, and it's very high performance in terms of query speed, joins, any sort of analytical process you want to build on top of this. The other great thing is now we've unlocked the potential for everybody else in the org with a SQL and a Python background to go and query that data. It's no problem. It's super easy. And so we're able to build use case after use case after use case. Cindy mentioned the 18 models, and this is definitely part of unlocking that scalability, is having the H3 indexing as part of the recipe. For the Wildfire AI project, we've been kind of working through this roadmap. We've mentioned some of these points. The other thing that kind of came up was that we have a bunch of ignition data at Xcel Energy regarding, an asset maybe has an outage, has a spark event. That data is coming through a bunch of different systems, and they don't necessarily talk to each other. And the data isn't always streamlined and captured in a way that makes it easy to work with. A lot of it is, text fields and things like that, where the technicians are putting in what they saw, what they observed from the investigation. And so we wanted to be able to use that data in a programmatic way. And so Cindy's team with the data science group, they've been able to go through, process that ignition data, and apply a bunch of labels to it. This was done manually up until recently, and it just took forever. And we use the LLM to help accelerate that process, and we'll let Cindy talk about that later. And then on top of that ignition data, once we have it labeled, we're able to do all sorts of feature engineering. So we're bringing the weather data, the outage data, the asset data all into the same location, and we're able to create likelihood models. So what is the likelihood of a outage today? What is the likelihood of an ignition today? And we're always looking to the future, 3, 4, 5 days in advance as well. And then also, what are the consequences? If a fire does break out, what do we do? What should be done? What mitigation options should we choose? And all of this goes into our analytics platform on Databricks, so we have intelligent reporting around that solution. And I'll turn it over to Cindy, kind of talk about what the work her team did on the ignition models.
Sure. Just to deep dive a little bit on what's listed here in number 3, but it's really just kind of focus your eyes on the right-hand side. When you think about that model itself, it was very inconsistent the way it was done in the past. You think about the current business process that was tied to this, and it was everything from overly intelligent, had historical knowledge from an engineer perspective, to sometimes it's interns looking at it, sometimes it's software folks, but it's everyone was looking at the situations that they were having to review, and it was a manual process of trying to figure out what is the likelihood, what should we be doing in this situation, and having manual notes feeding into a system. So we took that process and automated it all. We ran it through the language models. So it went from 64 hours a month of effort down to about an hour of processing. So when you think about just speed and consistency, that gets to the next line up, the accuracy. Because you went from having multiple different people having different perspectives, different level of experience, that accuracy went, which is, I went from 70% up to a 95% accuracy. Obviously, you've got consistency. This really does come back to standards. If you've got a model that you can program the standards into, it ties back to Xcel Energy's one-way efforts around trying to make sure that we have lean methodologies, making sure we're constantly improving how we're doing work, using technology as our enabler. That piece, though, alone, the accuracy amount was amazingly high. It's so uncommon. In other models we've done, it's yep, you get some improvement from a standardization, but to have that kind of a switch was so impressive to see, and the business teams were really, really helpful, because not only did it take time out of lots of people's days, but they also had a lot more confidence in the results. Now, to get there wasn't exactly an easy task. That one was a very, very heavy model to start. There was trained on a lot of data, but because they got that part of it working really well and they were able to refine it, it became a very lightweight distilled model at the end of the day. So it runs very fast on a very small amount, but it's customized based on all of the training that was done up front. So I can't stress enough. It's the amount of upfront effort on this one was heavy. It was big, but it got us to a point where now we have something that gives us a lot more accuracy, saved a lot more time, ties us back to like our overall initiatives at the company as a whole, just trying to make sure that we operate better and more efficiently, but also gets us to a point where, from a wildfire perspective, when you are in a situation where a lot of times you have to Kayla's point, like this isn't like 2 days out, you know that there's like high winds coming. There's situations where people like, there's a fire, like it's started, and you're just trying to like figure out like, what are you going to do? This, along with all of the other models I talked about, give us indication on how do we get in front of it and to the extent possible. And it's like, even if there's fires that have gone through from a restoration perspective, how do you quickly start to assess real time what type of materials we're going to need so we can restore electricity to our customers? Because at the end of the day, that's what we're here for. It's like I always tell like my team and like the others that I talk to across the company that at the end of it, all of this is very cool, but electricity is what fuels all of our day-to-day lives. And if all of a sudden you're in a situation where you can't charge your phone, you can't connect with your family, you can't like air condition or cool, or heat your home, like your life starts to like dry up really, really fast. So, I mean, everything that we can do from an energy perspective to make sure that we're facilitating the most efficient operation is really what this comes down to. So, tying it back to a little bit of real life there, it's like data and tech is cool, but at the end of the day, this is around how we make sure that all of your lives and our customers are benefiting from the work we do. So with that, I think wrapping it up, I'll hand it back to Giacomo.
Thanks, Cindy. One thing I just want to close with, kind of the theme at Lovelytics is, we're always want to speak with different partners about driving business value. So what we created was an outcome matrix where we put together the top business outcomes that address the top business challenges in both energy, utilities, oil, and gas. And from those business outcomes, we then, in theory, you pick an outcome, and then we show the various use cases that address that outcome, the data associated, and then the business value you should expect. So it's a really good tool to kind of work with different clients to understand, how they can drive the most business value. And if you're interested, feel free to stop by the Lovelytics booth, and we can talk more about that in general.